Okay, hello YouTubers, my name is Victor and this is my new Victron Energy inverter charger, the 1200 watt system. And this is going to be a fast review of the device and how to connect it to a computer and what you can be doing with the computer. So let's open the hood for getting better known to the device. And under the hood we can find the 16 amps fuse for the high voltage system it's protecting, and then we have the 230 amp fuse for the batteries. And actually at this point we're not connecting the batteries anywhere. It's actually going to this adapter, which is from an external hard drive, 12 volts and 2 amps. So we're going to pull the inverter with that one this time. Because my batteries are at my summer place, as are my solar panels. I have there a 1 kilowatt on-grid solar panel system. And this actually, on the device, this is the orange one, that's the programmable relay, which I have connected the wires to under the screws here. And that's not either going anywhere at this point, but it will be going to a heat boiler, where we're actually going to heat up some water if the sun is shining too much and the batteries can't take any more charge. And here on the next screws we have this temperature sensor for the batteries. That's a really cool thing which comes along the device, and I think that will save my batteries someday, because it stops charging and taking out some current from the batteries if the temperature of the battery is going too high. Then we have an empty RG45 connector and one which we have right now in use. We are going to connect our computer with this RG45 cable later on. And then we also have dip switches here, which we are able to program or configure some really simple tasks on the device, changing batteries and frequencies and stuff like that. Then we have the LEDs. Here's the green one for the inverters on, the yellow for charge and the red for alarms. And then here next to them we have the switch for the device, which we are going to actually now switch the device on. So now when we have it connected to a computer, no, we don't have it connected to a computer yet. So the device is going on, and that you can notice from the green light. So the device is on, and this is actually something I bought today. This is the Victron MK2 USB interface. And there was one setback with installing it to the computer. You shouldn't be using the Windows XP own driver installer, because it didn't find the drivers even though I have installed the program. So firstly, press cancel on the driver installer and then just use the program which comes from victronenergy.com. And that program will be installing this interface. So plug in interface, press cancel, and then install the inverter or the driver from Victron Energy. So this is our RG45 cable, which we are going to plug into the interface. Click like that, and as it's shown, this inverter turns off when you're connecting the interface. So that's something that should be happening. And then we have our computer over here. And we're going to select our port selection over there. And we are using COM port number 3. We can actually press here auto detect. Connect the cable and switch on the device. So now it's searching for a device which should be turned on. Should be, at least. So let's see what happens. Yes, target found. And as the target is found, the inverter turns on back again. So now it's retrieving like the product number and stuff like that, so that the program knows which are the settings on the device from previously. Yeah. So it's reading and retrieving and stuff like that. Yeah. Now we got the program opened over here. On the left side we have a MultiPlus. This is like a monitoring system. We are able to see what's the voltage output and input voltage, and what's the voltage in the batteries, how much current is drained from the batteries, and what's the frequency, and what's the state of the batteries. So state of charge. Here we have the green square sign indicating that the battery is full. Okay, actually we don't have any battery connected to the device right now, but the device thinks that our batteries are full. And then we also have by pressing there, we can get this monitoring system where we get some more detailed information about how much energy is going to the inverter and how much we are actually charging into the batteries. So that's that. We have the inverter over here. I have put it now to 244 volts because I hope you can be able to hear some noises really soon, and it's easier to hear than when we have some more voltage. But please remember to have 230 volts if you are in that area, because otherwise we will be breaking some electronics. So this is AES. This is the power saving system, which we are now going to turn on. So when we have a load which is lower than 50 watts, we will actually be using a modified sine wave which takes less energy to make. So now we have made a new setting, and then we're going to send the settings to our device. Send settings, and then send what? We're going to send only the modified settings, not all the settings from the whole device, but only that one particular one which we just altered. And then OK, and it sends the device. Takes a couple of seconds, and I'm not sure, you might be able to hear the sound actually changing in the inverter. So this is the sound with the modified sine wave, and then I restore it to the original settings. And I hope you were able to hear some difference in there. And then we also had a search mode, which makes a short wave, and then it waits for 1 second, and then it makes a short wave again. That saves more battery. But if you are using some low loads, let's say for example table light, it will be turning on and off, on and off, on and off, like once per second. So that's maybe something that we're not hoping for, but let's test that one too. We're sending the data, then it takes a couple of seconds for a change to be made. And let's see, I put my phone really close to the device, and perhaps you are able to hear. So the device makes a short pulse, and then waits for 1 second, and then short pulse again. Let's put back the modified sine wave. And then we are also able to change the frequency of the system. Don't do this if you're not sure of what you're actually doing. We're going to change it from 50 Hz to 60 Hz, and you can actually, when you're sending the information, you can actually hear the frequency changing in the device. So let's put my phone close again, and hopefully you're able to hear something. Like that. And now, as you see here in the monitoring, we also have 60 Hz output for a while. And here we are able to make some other settings, for example the UPS function. So this is an uninterruptible power supply, so this device will turn on its own power when the power grid is lost. And the dynamic current limiter, this is really nice to use when you have a small generator, for example, giving current or energy to your house. You can limit it, for example, to 5 amps, and the device will never take more than 5 amps from the generator, and it will provide the rest of the amps by itself. And then we have the charger here. Not much about that. You are able to change the battery types here. We're not going to change that. And yeah, lots of different things. because we are not actually having a battery connected to the device right now, we are not going to change that. Then you are able to change the battery capacity from this page, and then the next page we are able to make some adjustments to our relay, which we have here in our device. The orange one, that's the relay. And we're going to, here we have some settings to it. The relay or the virtual switch will turn on when we have a voltage higher than 14.5 volts. For 1 second the switch will be turning on, and in this case it will be driving our boiler heater. And then when the voltage drops back to 40.4, it will turn off the heater. And then we have the last option here. Do not switch off within 1 minute from switch on. So this makes the relay not to tick on, tick off, tick on, tick off. And then we have our last safety precaution over here. We have the change inverter period time on UDC. So when the voltage in the batteries are over 15.2 volts for 2 seconds, it will change the frequency of our device. Let's change this to 53 hertz. And this will actually make our solar panel inverters to turn off when the frequency is high, or it's more high than regularly. So that will turn off the inverters. For the solar panels, more of that later on. And then we also have, when we have solar panels, they are actually going to make some energy. So we are primarily going to use this inverter for our system. But when we have too much load on the system, let's say more than 1,200 watts, then we are actually going to pull the energy from our grid. And when the power used is lowered once again to, let's say, 1,100 watts for a period of 1 minute, then it will turn off the grid, and we will be only on solar or battery power once again. And here's also safety precaution. If the grid is still existing and we have a battery which is lower than 11.5 volts, let's change that one to 12 volts. Then it will be pulling the energy from the grid. This to make sure that we are not going to empty our batteries too soon. Make some settings there. And of course, when the voltage or the solar panels are going to charge the batteries once again, and we get 12.10 volts, then we are going to back to using only the inverter, not to the grid at all. So this was about that. Let's send the settings to our inverter, 50 hertz back, because otherwise we'll be breaking some stuff later on. Also we have the virtual panel over here, which we're able to use and get some basic information from it. We should be getting some basic information, for example overload or something like that, but actually right now it's not showing us anything. I'm not sure why. But yeah, that was about that. Hopefully you got something from this, and I will be posting some more videos of my inverter later on when I'm going to connect it actually to my solar panel system and to my battery bank. And yeah, thank you for watching, and well, let's say, remember to eat carrots.